doesn't leave mantises any chance of survival. The creature called a hairworm. This is just an invertebrate, but it can take over the mind of a mantis and fill its entire body. Well, before this happens, the hairworm makes a rather difficult journey to get to the final destination and carry out its plan. It all starts with eggs laid in a river or pond. Over time, they develop into larvae eaten by other aquatic insects. Or rather, insects just think they're eating them. Though actually, the hairworm larva just needs to hitch a ride to get into someone else's body. Once inside, it burrows into the flesh of the host, curls up, grows a hard shell, and waits. It doesn't take long before the insect matures, grows wings, and emerges from the water. That's quite handy, because the hairworm larva has great plans for the future. It needs to get the mantis to eat the host insect. And that's when the real life of an adult hairworm begins. The life of a terrifying parasite. But the main goal of any living creature is to leave offspring. So in order to leave offspring, the hairworm needs to get into the water. The mantis must deliver the parasite there, though it usually prefers to stay away from water, not to become easy prey for birds and fish. The hairworm needs to make an effort. It affects the chemicals in the mantis brain that make the insect wander mindlessly until it reaches water. But the mantis doesn't just fall into the water. Once near water, it's affected by the light that reflects off the surface of the water and jumps there. The hairworm almost immediately gets out of the host body and swims away. Where to? To breed, of course, and find new hosts. The larva turns into a worm, eating fats in the body of its host, which are a source of energy. So the mantis stops developing. It stops growing and mating. Perhaps it feels exhausted, but this is still not enough. The hairworm must be certain that its host doesn't get eaten on its way to the water, and it makes the victim act as cautiously as possible. This is not true only for mantises. Other insects, like, for example, crickets, also become victims of hairworms. Crickets infected by hairworms keep silent and lose their chirp because this sound attracts predators. Also, some scientists believe the hairworm shares its immune system with the victims in order to maintain their health and not accidentally kill them ahead of time. This is some weird care. Although the worm inside the host can easily grow up to 24 inches long, this doesn't make the victim grow as well. Though this doesn't mean the insects infected by parasites look the same as other insects. I already mentioned that hairworms eat fats and prevent their host from growing. Indeed, even adult infected mantises or crickets look more like, well, teenagers. Affected insects have shorter legs and wings and different antennae. In short, if you put an infected insect and an ordinary one next to each other, you'll see the difference right away. Hairworms get really big, and it seems like not a single living creature can survive coexisting with such a neighbor. As soon as the worm leaves the body of the host, the latter is supposed to die right away. But then we found out mantises and crickets are damn tenacious, guys. Yes, they can drown if they're swept away by the current. Most likely this is what'll happen. But otherwise these insects manage to survive living with the hairworm, or even several of them. Infected mantises simply become normal again and keep living as parasites are not always creatures that simply eat their hosts. Frankly, this even seems to be the best option, compared to the creatures that turn the owners into zombies. But how do they do it? Do they get into the animal's brain and whisper things to it? You're not you anymore. Now you are me. Actually, in order to study how parasites take over someone's mind, they even created a new branch of science called neuroparasitology. Host-parasite interactions, of course, didn't appear yesterday. It took evolution millions of years to come up with something like this, but it seems that in the end, it all comes down to complex brain chemistry. Very, very complex brain chemistry. Depending on the result the parasite strives to achieve, it affects the neural mechanisms through some chemicals. For example, the fungus cordyceps uses certain but still uncharted chemicals to cause ants to climb as high as possible on a plant and stay there until the fungus completely consumes the insect. A parasitic worm with the complex name lancet liverfluke also affects ants' navigational skills so that the insect climbs higher on the grass and gets eaten by some cow. The hairworms I already mentioned force mantises and other terrestrial insects into the water in a similar way. Other chemicals activate the bodyguard function in insects. Anyway, that's what scientists call it. But I'd say brain chemicals make caterpillars and ladybugs twitch their bodies, scaring away predators. This helps the offspring of parasites survive. And you know what? Scientists managed to discover many species with similar parasitic behavior. They even created a new scientific branch. But this didn't make the principles of how chemicals work any clearer. People, of course, continue their research, but in most scientific articles, you'll only find sentences like, and then the parasite sprays something on the victim's brain, and it's done. What exactly is it spraying? How does it work? We have no clue. Toxoplasmosis still remains the best studied case. That's a disease caused by the protozoan parasite Toxoplasma gondii. It infects rodents, lowers their dislike for cats, dooming their host to a certain death. Eventually the parasite needs to get into the cat's body, so the rodent has to give it a ride there. There are still so many different mysterious parasites. Take Saculina, for example. Ever heard of it? It's actually a barnacle that looks like a shell, But unlike most barnacles which simply stick to the rock and filter food from the water, Sacculina has evolved to become a parasite. The microscopic larva of Sacculina seeks out the unsuspecting crab using specialized sensory organs. Then it attaches to the most vulnerable part of the shell, and after a while, just like a tough parasite is supposed to, it takes over the body and mind of the host. It prevents the crab from breeding, and then turns it into a caring nanny. The crab tends to the offspring of Sacculina as if it was its own. And it doesn't matter if the parasite targets a male. The same mysterious chemicals will affect the hormones, convince the poor animal that he's female, and should act like a female.